Science, we are going to today be talking about everything that we've learned so far online, our distance, our displacement, our speed, and our velocity. Now, we haven't talked too much about speed and velocity, but we are going to go through one problem together and implement all of those ideas together in one problem. I think this way you're going to have a better idea of how to calculate the speed and velocity, and everything's going to really come together and make a lot more sense. So let's get started here. I have some problems we're going to go over. There's two problems. You're going to see these problems posted with the video, so you'll be able to physically see them. I would highly recommend writing them down as well and doing the work in like a notebook. I think that would be very beneficial to you. First problem, a boy runs 300 meters north, so M for meters. Then he runs 750 meters west. He runs 1,100 meters south. And 60 meters east. Finally, he runs 1,700 meters north again. The first thing that we are going to be solving for in this equation is our distance. Remember, distance is just adding the totals all together. So we're going to add and subtract our norths and souths and then our easts and wests. But the direction really doesn't matter with our distance. So 300 plus 750 plus 1,100 plus 60 plus 1,700 is going to give us a total of 3,910 meters. No direction needed. It's everything added together. Our displacement, which is the next thing we're solving for, is where our directions start to matter. So for our displacement, we are going to do our triangle, our Pythagorean theorem. And we're going to solve for that hypotenuse, that's c squared. Before we do that, let's add our legs together. Right here, I have 2 going north. 300 plus 1,700, that is 2,000 meters. But I have a south here, so I now have to subtract 2,000 from 1,100 is going to give me, just a second, yep, the 900 I'm looking for. So I'm going to put the 900 on this side, specifically because I like that the up and down is my north and south. You definitely don't have to do it that way. Do it whatever way makes the most sense to you. I am going to put an arrow though going up, so remember that that's north. You could also label that as north, whatever you like. Now the other two is my east and west, 750 minus 60. And that should give us 690 meters. And that would be going in the west direction because that is where our higher number is located. All right, now we have all we need to solve for our hypotenuse. So remember, it doesn't matter right now which one goes first, which one goes second. 690 squared plus 900 squared equals our c squared, our hypotenuse. All right. Let's take a second to do the math here. So when I do my two squareds here, I come up with 1,286,100 equals the squared. So now what we have to do to get rid of that squared is we have to square that number. All right. So let's give you guys a second to square that number. All right, and the answer I received for that is C equals 1,134.06. Can't see that? There you go. So that is our displacement, but we're not quite done yet. Displacement is where we look at our direction. So not only do we have to add our meters, we have to add a direction to our meters. So displacement 1,134.06 meters. We have north and then west. That is our final displacement answer. Now, still looking at the same problem here, we are going to try to find my speed, okay? Now, with my speed, marker will write nice for me here, that would be great. We are looking at distance over time. All right. Now for my speed, and this is kind of like my average speed here, I want it in meters per hour. All right. So we have our distance, right? Our D is going to be equal to 3,910. That's the distance that we found up here, and that was in meters. However, the time we don't have yet. I have not given us the time. So my time I'm going to give you is, this happened in 15 minutes. What's wrong with this? Well, I gave it to you in minutes. We need it in hours. If I know that there are 60 minutes in an hour, and I take 60 divided by 15, I'm going to get 4. Because 15 minutes goes into 60 4 times. Just double check my math there on that. Yep. However, 4 is not the number I want to put there because I didn't do 4 hours. Since I know it came in 4 times, think about it kind of like money. 4 quarters gives me $1. It's a quarter. Now all we have to do is divide. 3,910 divided by 0.25 is going to give us a speed of 15,640 meters per hour. All right. So that is our total speed because we did distance over time. Now the last part to this is going to be our velocity. Velocity is a little bit more tricky because instead of using distance, we're using our displacement over time. All right, now we already figured out our time. So we know our time is 0.25 hours. We're going to keep it in hours for our velocity. But now we have to take a look at our displacement. Guess what? We already found our displacement as well. That was at the beginning. That's our 1,134.06 meters northwest. Make sure you have that label. Remember, I said anytime you see the word displacement, you need to put direction. Same thing here. Velocity involves displacement, so that means it needs a direction. So I have my displacement 1,134.06 meters northwest over my time in hours, 0.25 hours. And that is going to give me an answer, do the math, of 4,000 936. Work is dying out, I'm in here. 0.24 meters northwest per hour. Okay, now speed, I said before, is like our average speed. So how fast the boy is running on average. My velocity is more so my length from my beginning to end. This is my speed versus my total length from the beginning time to the end time. All right, that's kind of the big difference there. So this is tying everything together: distance, displacement, speed, velocity. There are going to be some problems on this. Please watch part 2 of my video next before you start the problems, because part 2 is going to talk about some river problems. We're going to introduce how problems are different based on the river. And this is going to come back to our point of view, or our frame of reference that we talked about at the beginning of this unit. All right, hang tight. Be sure to watch part 2 next.